This is Bob Capetta from the University of Illinois at Chicago. This lesson is Math 121 Pre-Calculus Final Exam Review, Part 2, Problems 1 through 4. First question is 4 sine squared theta minus 3 equals 0. Adding 3 to both sides, we then get 4 sine squared theta is 3. Dividing by 4, sine squared theta is 3/4. We want to take the square root of both sides, but if you do that, you've got to put in plus or minus. So the square root of sine squared is actually the absolute value of sine theta. So taking the square root of both sides, we get that sine theta is plus or minus the square root of 3/4, which is plus or minus root 3 over root 4, but root 4 is 2. So we get sine of theta is plus or minus root 3 over 2. So there's two equations we have to solve. Sine theta is root 3 over 2, and sine theta is negative root 3 over 2. So for the first piece, if sine theta is positive root 3 over 2, the reference angle is pi over 3. And we need answers in quadrant 1 and quadrant 2. That's where sine is positive. In quadrant 1, of course, it's pi over 3. In quadrant 2, it would be pi minus pi over 3, or 2 pi over 3. Now, here, sine of theta is negative root 3 over 2. The reference angle is still pi over 3. But now I'm going to need quadrant 3 and quadrant 4 answers. That's where sine is negative. Quadrant 3, pi plus pi over 3, or 4 pi over 3. Quadrant 4, 2 pi minus pi over 3, 5 pi over 3. So these are my four answers between 0 and 2 pi. But if I want to get all of them, I have to add 2 pi k. So pi over 3 plus 2 pi k, 2 pi over 3 plus 2 pi k, 4 pi over 3 plus 2 pi k, 5 pi over 3 plus 2 pi k, where k is any integer. However, notice 4 pi over 3 is pi more than pi over 3. And 5 pi over 3 is pi more than 2 pi over 3. So if I wanted, I could actually write this in a slightly simpler fashion, recognizing it's pi over 3 plus pi k and 2 pi over 3 plus pi k, where k is any integer. So I mean, the first answer is right. This isn't wrong. This is just a little simpler if we want to write it that way. Next up, we have tan squared theta minus 1 is 0. Adding 1 to both sides, tan squared theta is 1. Taking the square root of both sides, tan theta plus or minus 1. So again, two equations to solve. Tan theta is 1, or tan theta is negative 1. Reference angle in each case will be pi over 4. But if tan theta is 1, tangent is positive in quadrant 1 and quadrant 3. Quadrant 1, it's pi over 4. Quadrant 3, pi plus pi over 4, or 5 pi over 4. Tangent of theta is negative 1. Again, reference angle is pi over 4. But tangent is negative in quadrant 2 and quadrant 4. Quadrant 2, 2 pi minus pi over 4. Check that, pi minus pi over 4. 3 pi over 4. Quadrant 4, 2 pi minus pi over 4. 7 pi over 4. So we have those four answers, and we could say plus 2 pi k plus 2 pi k plus 2 pi k plus 2 pi k. Except in reality, the period of the tangent function is pi. So you'll notice pi over 4, 5 pi over 4 differ by pi. So I can get rid of this 5 pi over 4 by making that pi over 4 plus pi k. Same thing, 3 pi over 4 and 7 pi over 4 differ by pi. So if I just stick with the pi over 4 and the 3 pi over 4 solution, quadrant 1 and quadrant 2, and then add pi k to each, that will give me all of my answers, recognizing the period of the tangent function is pi. Again, this first answer is not wrong. This is just a slightly nicer way to express the solution. Next up, we have 2 cos theta plus 1 is 0, adding negative 1 to both sides. 2 cos theta is negative 1. Dividing by 2, cos theta is negative 1/2. Cos 2 theta is negative 1/2. I like to introduce a new variable, so I'm going to say let z equal 2 theta. Then the problem becomes cos of z equals negative 1/2. Now I need my reference angle. Cos of pi over 3 is 1/2, so my reference angle is pi over 3. Which quadrants is cosine negative? That would be 2 and 3. Quadrant 2, pi minus pi over 3. Pi minus pi over 3, 2 pi over 3. Quadrant 3, pi plus pi over 3, 4 pi over 3. So those are z. So I get z, I get 2 theta is 2 pi over 3. I get 2 theta is 4 pi over 3 plus 2 pi k. So for my first example, z is 2 pi over 3 plus 2 pi k. But z is 2 theta, so 2 theta is 2 pi over 3 plus 2 pi k. Similarly over here, Z is 4 pi over 3 plus 2 pi k. But what is Z? Z is really 2 theta. So we get 2 theta is 4 pi over 3 plus 2 pi k. To solve for theta, multiply both sides by 1/2. I have these two equations. Multiplying both sides by 1/2 will enable me to solve for theta. So here's where we are. In our first case, multiply this by 1/2, this by 1/2, this by 1/2. A half of 2 theta is theta. A half of 2 pi over 3 is pi over 3, and a half of 2 pi k is just pi k. So we get theta is pi over 3 plus 2 pi, check that, plus pi k on that side. Similarly over here, multiply by a half, multiply by a half, multiply by a half. A half of 2 theta is theta. A half of 4 pi over 3 is 2 pi over 3. And a half of 2 pi k is just pi k. So that's our general solution, this and this, for any integer k. Now if I want to get the values between 0 and 2 pi, let's plug in values for k and see what we get. So we see this is our solution. If I let k equal 0, I just get pi over 3, 2 pi over 3. If I let k equal 1, that's pi over 3 plus pi, which becomes 4 pi over 3. 2 pi over 3 plus pi becomes 5 pi over 3. If I would add 2 pi, obviously I am beyond my usual 0 to 2 pi solution. So I have 4 answers, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, in the interval from 0 to 2 pi. So we often ask for that, all the solutions from 0 to 2 pi, and we get those 4. Our next question is cos 6 theta plus cos 2 theta is 0. This is a product to sum identity question. I need to look up cos A plus cos B to see what sort of formula I need. And we get cos A plus cos B is 2 cos A plus B over 2 times cos A minus B over 2. A will be 6 theta and B will be 2 theta. So 6 theta plus 2 theta, 8 theta over 2, 4 theta. 6 theta minus 2 theta, 4 theta over 2 would be 2 theta. So I need cos 6 theta plus cos 2 theta is 0, so that will mean 2 cos 4 theta cos 2 theta will be 0. And if that's the case, cos 4 theta is 0 or cos 2 theta is 0. Now when is cosine 0? That's when the x value is 0. That's what pi over 2 and 3 pi over 2. But let's use some variables. Let z equal 4 theta and let w equal 2 theta just to keep them straight. So it becomes cos z is 0 or cos w is 0. And again, cosine is 0 at pi over 2 and 3 pi over 2. So z is pi over 2 plus 2 pi k, 3 pi over 2 plus 2 pi k. Same thing for w. If cos w is 0, w is pi over 2 plus 2 pi k. W is 3 pi over 2 plus 2 pi k. But z is 4 theta, w is 2 theta. So using these 4 equations, let's make that substitution. So if 4 theta is pi over 2 plus 2 pi k, and 4 theta is 3 pi over 2 plus 2 pi k, similarly over here, 2 theta is pi over 2 plus 2 pi k, 2 theta is 3 pi over 2 plus 2 pi k, but we need to solve for theta. Multiply by 1/4, theta pi over 8 plus 2 pi k over 4, pi over 2k. Similarly, theta 3 pi over 8 plus pi k over 2. So we get that with our fractions. Over on this side, we're going to divide by 2. So if I have 2 theta is pi over 2 plus 2 pi k, multiply by 1/2. Theta is pi over 4 plus pi k. And the second example, multiply by 1/2, that'll be 3 pi over 4 plus pi k, which you can see that we get. So we have our general solution, 1, 2, 3, 4 solutions there for any integer k. So we write the answer that way. Pi over 8 plus pi k over 2, 3 pi over 8 plus pi k over 2, pi over 4 plus pi k, 3 pi over 4 plus pi k, where k is any integer. Our next question is sine of pi over 12. That's going to require a half angle. So a half of pi over 6 is pi over 12. We want to keep that in mind. And here's our identity. Sine of theta over 2 is plus or minus the square root of 1 minus cos theta over 2. We've got to choose whether it's the plus or the minus. Pi over 12 is in quadrant 1, so it'll be plus. Again, pi over 12 is a half of pi over 6, or pi over 6 over 2. We're going to replace that theta with pi over 6. It'll be sine pi over 6 over 2 is plus 1 minus cos pi over 6 over 2. Cos of pi over 6 is root 3 over 2. So if we rewrite this, 1 over 2 is a half root 3 over 2 divided by 2. Root 3 over 2 times a half, that's root 3 over 4 in arithmetic. And let's get a common denominator here. So 1/2 is 2/4. So the top is root 2 minus root 3. The bottom is root 4. So what's that going to give us? Root 2 minus root 3 over root 4, which is 2. So the sine of pi over 12 is root 2 minus root 3 all over 2. Other ways to write that, but that is a reasonable way for sure. Next up, we have the tangent of 22.5 degrees. Here's the formula I'm going to choose to use. 22.5 degrees is 45 degrees divided by 2. So I'm going to replace this theta with 45 degrees. So tangent of 45 degrees over 2 is 1 minus cos 45 degrees over sine 45 degrees. I'm choosing to use 1 over root 2 for each of these. Cos of 45 is 1 over root 2. Sine of 45 is 1 over root 2. Now to simplify this, multiply the top by root 2, multiply the bottom by root 2. Root 2 times 1 is root 2. Root 2 times 1 over root 2 is just 1. So I'm going to get root 2 minus 1 upstairs. Root 2 times 1 over root 2 is just 1 downstairs, which of course becomes root 2 minus 1. So the tangent of 22.5 degrees is the square root of 2 minus 1. Next up, we have cos 50 degrees, cos 20 degrees, plus sine 50 degrees, sine 20 degrees. I need to find an identity that goes cos A, cos B, plus sine A, sine B. Looking at the identities, I see that the following will work. Cos of A minus B is cos A, cos B, plus sine A, sine B. But let's switch the order. Let's put the right-hand side first and the left-hand side second. And I'm going to substitute 50 degrees for A, 20 degrees for B. 50 for A, 20 for B, 50 for A, 20 for B. And it'll become cos 50, cos 20, plus sine 50, sine 20 is cos 50 minus 20. But what is 50 minus 20? It's just 30 degrees. And what is the cosine of 30 degrees? The answer to that, of course, is root 3 over 2. So cos 50 degrees, cos 20 degrees, plus sine 50 degrees, sine 20 degrees equals square root of 3 over 2. And that will conclude this lesson.